All right, welcome back. We are on problem number 3. And yeah, let's just keep going. All right, problem number 3 tells me a rescue pilot drops a survival kit while her plane is flying at an altitude of 2,000 meters with a forward velocity of 100 meters per second. If air friction is disregarded, how far in advance of the starving explorer's drop zone should she release the package? I'm not going to draw a diagram, although that really might be helpful for you in this case. I find that when things are dropped and moving at the same time, I need a visualization. I'm going to skip that step, however, to just go ahead and list what we know, list our variables. But I encourage you, if you ever need a picture, to draw one for yourself, so you understand what's going on. So again, I'm going to start with my familiar always steps of A being 0 meters per second squared in the x direction and A being negative, again for down, 9.8 meters per second squared in the y direction. I also note in this case that Vx, again my initial and my final, are the same in the x direction, so I'm just going to write them once. If you choose to write Vi equals Vf equals Vx, or list them as two separate things with the same number, that is completely fine. I'm just going to list it as Vx, because this 0 tells me I only have one value. It's not going to change. My final and my initial are going to be the same. And I know that's 100 meters per second. Some other things that I know my initial height is that 2,000 meter altitude. That's where the box is dropped from. And then I know it's going to hit the ground. So I'm going to call the ground 0. Now, you might notice from this that what you could do is just go ahead and combine those and say that delta y is negative 2,000 meters, and that works perfectly as well. And then finally, I know it has a horizontal speed, but the plane does not mention anything about a vertical speed. I'm assuming that my airplane, well, I am going to draw it anyway, is just going straight horizontally before this package is dropped. I'm not going to be worried about any y velocity, so that means that my initial velocity in the y direction is 0 meters per second. Okay, I am tasked with figuring out how far in advance of the drop zone she should pick it. She should drop it, and for that I'm looking for a delta x. Again, how far? Far is either going to ask me usually a delta x or a delta y, and I have delta y, so let's figure out delta x. In order to do that, I'm going to actually figure out time from the y direction and then use that to figure out my delta x. I know that I need to find time because when I plug into my delta x equals Vxt equation, I don't have two things. I only have the one. So I'm going to use my y direction to help me in the x. So delta y, remember, equals Vi in the y direction times t plus 1/2 at squared. I know that my delta y is negative 2,000 meters. My initial velocity is 0, so that whole term is going to go away. I don't have to worry about that. 1/2 times negative 9.8 times t, which is what I'm looking for. Don't forget that that t is squared. If I plug into my calculator to solve this, I get that t equals 20.20 seconds. Now I can go back to my delta x equation. Delta x equals Vix, or Vx, remember it's all the same t. Plugging in, delta x equals Vx, which is 100, times 20.20, which gives me 2020 meters, or 2,020 meters, which is my correct answer.